Gold mining in the Alaskan interior employed bucket line dredges as a preferred technology. While the dredges are massive and visually overbearing, the basic concept is very simple. Buckets scoop up the gravel from the water body and dump it into bins inside the dredge. Water is pumped in to separate the gold from the gravel, and the gravel, or tailings, is then dumped out the back. Bucket-line gold dredges are extremely efficient and cost-effective to operate, but they caused irreparable damage to river channels and riparian areas. As does most industrial resource extraction, whether it be strip mining, timber cutting, or drilling for oil and gas. Frequent and dangerous results: the loss of habitat and an increase in pollutants and waste, with a concurrent decrease in soil, water, and air quality. But wildness is a life-affirming, persistent, and trustworthy creature. Left to its own predilections, it points the way to renewal, illuminating both ecological well-being and beauty, even from the landscapes overrun by greed and its formidable technologies. How to move forward with wildness as a trusted guide? We can start with the perceptions of Thomas Berry, who contends that the greatest present-day ecological threat is the Western industrial economy and the growth of modern technological culture. The evidence for this? Extreme weather and accelerating rates of species extinction. As an antidote, Berry proposes that we might begin by recognizing that the life community, the community of all living species, including the human, is the greater reality and the greater value. The primary concern of the human community must be the preservation and enhancement of this comprehensive community, even for the sake of its own survival. How can this be achieved? The everyday relevance of a vernacular approach to ecological restoration is that it seeks to embed the human into the long-term health of ecosystems, or better put, the life community. Key to this vernacular approach is that it recognizes that ecological restoration applies not only to the regeneration of damaged landscapes and natural systems, for example, revitalizing forests that have been clear-cut for timber, and the cleanup of brownfields and other polluted lands. As importantly, it recognizes ecosystem renewal as the daily part and parcel of meeting basic, non-manufactured human needs, as with the food we grow and the electricity we generate. A vernacular approach to ecological restoration assumes that bioregionally based cultural values, complemented by properly considered and scaled community designs and technologies, is a durable foundation for integrating human activities within the wider life community. Ecological restoration is a long-term commitment to regenerating the ecological resiliency of life places, alive yet susceptible to decay, and always in need of renewal, with human participation. These two endeavors, nourishment and regeneration, need to be integrated for the Earth community to thrive. When the Chena River surged and overflowed its banks in 1967, it flooded large parts of Fairbanks, Alaska. The solution by the Army Corps of Engineers was the Moose Creek Dam and a levee along 21 miles of the Tanana River. In its mammoth scale, it is a vivid example of the engineering mindset that seeks to fortify barriers to, rather than complementing and integrating, the local ecology, especially its hydrology or water network. Community designs, like the Moose Creek Dam, and modern technologies are not neutral. Cars, for example, have encouraged suburban sprawl as a favored community design, remade streets, the hub of so much community vitality, for its own purposes, and altered local and planetary ecologies in its contribution to climate change and extreme weather. The automobile is a present reminder of the consequences of unexamined and ever-expanding tools that breach cultural and ecological thresholds, diminishing our common life. But the Army Corps approach is not the only choice. Vernacular implies rootedness and abode, and sustenance derived from reciprocity patterns embedded in our shared community life. The picture throughout human history is that ecosystem wisdom expresses itself through the vernacular by the ways that people act collectively and daily in response to the opportunities and constraints provided by their local ecosystems. This is especially so for technologies thought to help with human endeavors. Green infrastructures are vibrant examples of human scale as they have become a viable alternative to conventional stormwater management. It accomplishes this with a basic premise: imitate natural systems in the wider context of watersheds and bioregions. We can ask ourselves, what would have been the outcome if the Army Corps had considered this as an alternative? Where can we find guidance for ecologically based community designs and appropriate technology? In wild natural areas left untainted by industrial abuse. One of the major influences on Denali's extensive and protected ecosystems is the Alaska Range, the massive wall of rock, glacial ice, and snow running southwest to northeast. Nudging the range are boreal forests that include black spruce trees and white spruce and paper birch forests. Wildness, if it can be listened to, can be an illuminating guide to community identity, designs, and decision-making. In unison with mature ecological areas in their characteristics and biological richness are lessons for vernacular ecological restoration to be successful. Ecologists have described the tendencies for undisturbed natural systems to move through different life stages, known as natural succession, beginning in pioneer stages and culminating in mature or climax ones. A coherent regional design pattern can be found in the progression of vegetation through natural succession to climax. Natural succession can be understood as the unfolding of ecosystems distinguished by different holistic features as they age. For example, a lawn in suburbia, left unattended, will mature through being a meadow and woods into a forest with a characteristically high level of species diversity, total biomass, and energy-efficient pathways for solar income to move. A mature climax ecosystem offers design criteria for both restoration of natural systems and to match local resources to the supply of energy, food, and water in meeting basic human needs in a stable manner. And there is no better place to witness and understand succession than in large undisturbed areas like Denali National Park. Glacial rivers, such as the Savage River, are constantly reshaping the land by shifting channels and creating new floodplain deposits. The park, and this river itself, is deeply influenced by earth movements, glaciers, permafrost, water, and fire, as the Alaska Range and the northern boreal forest, especially taiga forests, attest to. The more upriver part, originally carved out by glaciers, is a braided river, characterized by little vegetation and a fair number of shallow channels that are continually changing their course across wide beds of gravel floodplains. The Savage River, heading downriver, transforms itself from a glacially scoured braided river to a faster moving one, with a single channel through a V-shaped canyon typical of river erosion. The dynamic history of the Savage River has not only earned its name, but its overall hydrologic and geologic makeup makes it especially valuable as a guide to restoration efforts. A simple and straightforward way of assessing community designs and technologies is to ask questions of them to gauge whether they are helping to move community change towards climax stages and away from pioneer ones. The following are some questions based on design criteria derived from natural succession, which can be rephrased as to their importance for local organic farming. We can ask, are material cycles being closed? The answer lies in recognizing that soil vitality is the foundation of organic farming. That means replacing fossil fuel-based fertilizers and pesticides with organic amendments, including green manures and composted humus. This can also direct attention to using farming equipment that does not overly compact soil. We can ask, is the total biomass increasing in the watershed and bioregion? The answer points in the direction of converting fallow lands to farming, using more dense crop rotations. This also includes woodland protection, resulting in more mature forests that helps running water and biodiversity stay alive and healthy. We can ask, are decentralized pathways of material and energy use being created? The answer reveals itself when soil building and biological pest control are replacing fertilizers and pesticides, and renewable energy is being used for everyday farming activities. We can ask, are plant and species diversity increasing? The evidence for this answer is when standard agricultural practices are moving away from single-crop monoculture and towards a polyculture with more diversified planting designs. Human designs can instill the attributes of mature ecosystems into our built environments, making them more resilient and beautiful. In 1933, the Nebesna Road was built to carry in supplies to the Nebesna mine in Alaska and to ship out its ore. Today it provides a northern entry into the Wrangell St. Elias National Park and Preserve. Nebesna Road runs west to east starting at Slana. Looking north from this road are the Mentasta Mountains. These mountains are at the eastern end of the Alaska Range and are distinguished by their rounded peaks worn down by weather and erosion. Looking south are the Wrangell Mountains. They are the result of formidable geological forces. For example, the Wrangell Mountains are almost entirely volcanic in origin. Boreal forest abuts both the Mentasta and Wrangell mountain ranges and can be recognized by the spruce, aspen, and poplar forest stands with muskeg and tussocks as ground cover. As powerful as the geological influences are, the steady and long-term effects of rivers and glaciers slowly and continually erode and alter the landscape. Wrangell St. Elias National Park is another undisturbed area that can provide insight into understanding natural scales of places as the context for appropriate technology and the limits of technology in general. With technology so pervasive, how can we begin to appraise them as to their vernacular role in ecological restoration? We can start with a basic way of seeing. Each social environment, with its unique ecological setting, can be understood to have a corresponding set of natural scales, appropriate to a specific place. And when our technologies and community designs exceed the capacities of these natural scales, for example, transportation infrastructures, we have exceeding levels of dysfunction, as when we waste hours in traffic jams traveling to and from work. When meeting basic human needs unfolds within these natural scales, we can say that it has right proportions. Right proportions then become a natural scale appropriate to a specific place. Right proportionality, often with common sense, is a well-founded friend. It is behind such satisfying utterances as, "That fits well," "That always wanted to belong there," "It's comfortable around here," or "It just wanted to turn out that way." But right proportions can also express themselves as learned design sensibilities that results in what Lewis Mumford called balance and wholeness. Right proportions grounds what is doable and proper to place-specific form and size. When coupled to local and practical technologies, satisfying personal and social relationships often result with ecological relevance. This is why right proportions are the framework and promise for appropriate technology. Appropriate technology begins with the practicality of E.F. Schumacher's small is beautiful vision to maximize local production from local resources for local use. This approach advocates for tools through the lens of small, simple, and cost savings. Schumacher recognized the value of meaningful work when making needed things. This has three purposes: to produce necessary and useful goods and services, to enable us to use and perfect our gifts and skills, and to serve and learn to collaborate with other people. What are some of the defining characteristics of appropriate technology, with examples drawn from organic farming? First is the subordination of tools to human purposes and is a means to personal and communal ends. Bioregionally based agricultural efforts accomplishes this by aligning community food production and health with local ownership and control. Second are access to softer, smaller tools under the control of users instead of oversized and centralized ones. Most farming equipment is designed and manufactured for industrial agriculture, resulting in large-scale heavy equipment that is expensive to operate and repair. Organic farms require different equipment choices, especially ones that don't compact the soil as much, are electric, and can be largely serviced by farmers themselves. Third is keeping the consequences of technology use as tangible as possible. A robust constellation of small organic farms can replace the more industrial and distant agriculture. The results are direct and visible. You know where your food is coming from, and often the farmers who grow it, and food is healthier and tastes better. As Lanza del Vasto, Western disciple of Gandhi, wrote about farming, find the shortest, simplest way between the earth, the hands, and the mouth. Schumacher was not doctrinaire about everything being small and local. What he provides is a trustworthy reference point. The tensions between decision-making and consequence, production and consumption, are kept as tangible and visible as usefully possible. Building a robust bioregional network for growing and distributing nutritious food exemplifies this. We can make Schumacher's small is beautiful approach even more relevant by integrating it with an essential ecological dimension. How does the technology embed local cultures in the ecosystem process to the advantage of biodiversity and subsistence lifestyles? Here we find common cause between right proportions, appropriate technology, and natural succession. There can be a harmony between families and communities and the natural order of scales they reside within. And this harmony rests on the appropriateness of a relationship for living in a certain place. Vernacular ecological restoration, as cultural practice and technique, shares much with good organic farming. Outside and in the circle of life, restoration work rests on careful observation and unfolds best when natural diversity flourishes while human needs are satisfied. In the end, perhaps, what restorationists will have really accomplished will be more elementary. They will have returned to local culture a trust in the understanding of natural systems for cohesion and reciprocity. When that day comes, a change will have occurred. Our understanding of community will have deepened into shared local knowledge and traditions of living in places now beautiful enough to feed both belly and soul.